if the x is negative, then we must have the theta between the half pi and pi, right? What is the sign of the tangent in the quadrant 2? Negative, right? So in this quadrant 2, tangent theta is less than 0. So that means we just have the tangent theta equal to square root of the 1 minus x squared over x. We just get rid of those plus minus sign. Why? Because here x is negative. This is positive square root. Then this fraction as a whole thing is negative, right? So in either case, you always have the tangent of the arc cosine of the x equal to the square root of the 1 minus the x squared over x, no matter x is positive or negative. Now let's look at one more problem of this type, and let's look at the problem 34 on page 516. Page 516, problem 34. We need to evaluate secant of the arc sine x. So first, we let theta be arc sine x. So by the range of the arc sine function, we know theta is between negative half pi and half pi. Okay, and by the definition of this arc sine, we know sine theta is equal to x. So now this secant of arc sine x is equal to secant of theta. So now we need to express secant theta in terms of the sine theta so that we can express this in terms of x. And we know secant theta is equal to 1 over the cosine theta. And cosine theta is equal to plus minus the square root of 1 minus sine square theta. And then this guy is equal to plus minus 1 over the square root. Now let's replace this sine theta by x. So you have the 1 over square root of the 1 minus x squared. Now we need to determine the sine of this secant theta. And we know for the theta between the negative half pi and half pi, theta is either in the quadrant 1 or the quadrant 4. In these two quadrants, both cosine and secant are positive. So we have the secant theta greater than 0 or equal to 0. Then when we just take the positive sign at here, so that means secant of arc sine x is equal to positive 1 over the square root of 1 minus x squared. So in this way, we express this original expression as an algebraic expression of x. Any question? Now let's do a short review about the odd function and the even function, and then we get the odd and the even identities. So we'll talk about odd and even identities. So we know a function is called an odd function if f of the negative x is equal to negative f of x for all x in the domain. Okay, let me use a D for the domain. And for the even function, that is f of x, f of the negative x equal to f of x for all x, okay, in the domain. So this is the definition for the odd function and even function. Now let's look at the page 513 and let's look at the fig 6.4. So right now we have two angles, and this angle with the radian measure s, since the rotation is counterclockwise, so we got the positive radian measure, and we'll have another angle, and the radian measure is the negative s. Okay, so actually these two arc lengths are same, but they have the opposite sign. So now we know this point and this point, they are symmetric about this x-axis, right? So they must have the same x-coordinate and the opposite y-coordinates, right? So from this fig, we can immediately find sine of s, which is equal to y, and sine of the negative s is equal to negative y, right? And the cosine of s is equal to x. Cosine of the negative s is also equal to x. So let me write on this. Sine of s is equal to y. Sine of the negative s is equal to negative y. Cosine of s is equal to x. And this is the same as the cosine of the negative s. Okay? So we have this odd and the even identities. So first, we have the sine of the negative x equal to negative sine of x, right? We just replace this s by x. And we have the cosine of the negative x equal to cosine of x. And from these two identities, we may derive some other odd and even identities. So let's begin with the tangent of the negative x, which is equal to cosine of the negative x over the sine of the negative x. And since the cosine here we know is an even function, right? And the sine is odd function. So cosine of the negative x is just equal to cosine of x. sine of the negative x is equal to negative sine of x, and then this guy is equal to negative tangent of x. So you know, tangent is an odd function, right?